Welcome to Narayana Engineering College, Nellore. This is G.GOPI, working as adjunct faculty in Narayana Engineering College, Nellore. Today, we are going to discuss about the expanding horizons of mobile networks. If you look at the mobile phones used for 1G and 5G, there is quite a difference in the architecture of the telephone itself. The mobile communications started with the evolution of Graham Bell telephone, invention of telephone, then Marconi's invention of wireless transmission of electrical signals in 1895, and in 1973 Motorola made the first handheld phone, which is mobile. The first generation mobile communication started early in 1980s, and that time different countries have used different technologies for the purpose of mobile communication. For example, Europe has used Nordic mobile telephone, whereas UK has used total access communication system, and the one used by America is known as AMPS, and Japanese have started with the personal communication system PCS, which has evolved into JTACS. However, the initial first generation mobile communication has got certain limitations or drawbacks. The first among is there is no facility of handoff. By handoff, we mean as the subscriber moves from one area to the other area, there should not be interruption of the call between the change of BTS. Looking at these limitations, 2G system is evolved, and the first idea of evolving 2G is to have universal standard for all the countries, and the first one developed is GSM, Global System for Mobile Communication, and also the first generation is limitation is it is analog cellular network, whereas in the GSM the packet transmission or the data transmission also started in a small way. And if we look at the mobile system as a whole, it has got some subsystems like radio system, base station, then network subsystem, and operations subsystem. And these subsystems have got different roles to play, which we will be discussing later. The radio subsystem basically handles the signals in different frequencies. For example, in the 1G communications, the signals are in kilohertz range. When it comes to 2G, 800 megahertz is the band used, and 3G, 800 and 1900 megahertz bands are used. And the frequencies bands have increased as the generation has evolved. The radio subsystem has got an uplink and downlink. The frequency for the uplink and the downlink are kept purposely different so that the communication is enabled without any interference. The name cellular for the mobile communication came because of cellular concept. As we all know, there is limited bandwidth available for the cellular communications. In order to make efficient use of these available frequencies, this cellular concept has evolved, wherein the same frequencies used around one cell are used at other cells also, so that the frequency reuse is done. This concept has enabled the communication or the mobile communication to expand into all the areas where the customers need the services. In the GSM architecture, we can view it as a system having three subsets of system. BSS, for example, this gives the connectivity from the mobile subscriber to the first point of connectivity of the cellular providers, that is cell communication system providers, that is the communication between the cell phone and the BTS, base transmit receiver. And the next subsystem is NSS, wherein all the customer data and other required network operations are done. For example, the VLR and HLR. HLR registers the details of the mobile user in his own BTS, whereas VLR, whenever the mobile user moves from his own home station to the different location, it is recorded in the VLR and is kept track by the NSS system. And in order to have connectivity to the PSTN phones, there is connectivity network between the mobile network and the PSTN in the form of GMSC, gateway. And to enable 2G to handle the data networks, GPRS is introduced. This is introduced so that the existing voice communication elements are kept intact, whereas only add-on equipment is used so that data also can be transmitted using the same 2G network. Yeah, this GPRS is a separate equipment is attached to the existing equipment so that the data can be transmitted between the mobile users. Yeah, and this 2G data networks are enabled using GPRS initially with 2G, and then it is further increased from data rate of 115 kbps to 384 kbps by using edge technology. And in the same period, CDMA also is introduced so that it can handle even up to 2000 kbps. Yeah, CDMA is a novel concept where the entire band of frequency is used along with the code between the cellular users. This is more noise free and efficient, but the limitation for CDMA lies in the fact that when the user is moving with higher speeds, it will not be workable. In the 3G, higher frequencies are made use of so that the data rate can be increased. And these 3G standards are developed first by third generation partnership project. And all the details like the frequency bands to be used and the data rates to be used and how the handover happens, all these details are worked out in this third generation partnership project. Yeah, the detailed architecture of 3G UMTS is shown in the figure. As seen, it consists of radio network, then core network. In the radio network, the connectivity is between cellular mobile, cell mobile and BTS. And around 10 BTS are having one BSC. BSC controls the connectivity of various BTS with the customer. And this BSC is again connected to the MSC, Master Switching Center, wherein all the details of the customer is registered in HLR and VLR, and the connectivity to the PSTN network is made through another gateway, GMSC. So the Master Switching Center has got the billing and other facilities also, and every cellular call has to go through MSC for purpose of billing as well as for purpose of allocating the required radio channel to the customer. And further, if we see in the core network is connected to data network and thereby to the internet also, and PSTN. For this separate CS domain is used for connecting to the PSTN network, that is public switched telephone network. However, the speed of 3G is not enough for higher downloads, high speed downloads. So then came the idea of going for 4G, wherein the data speeds are expected to be higher. And the main concept used to enable higher data speed download is MIMO, that is multiple input and multiple output, wherein the multiple antennas are used both at the BTS as well as in the cellular phone also. To have multiple antennas in the cell phone, the antenna size has to be very small, and also to have higher speeds, high frequencies are used. In 4G, for example, 2.5G is the frequency used, so that the antenna lambda by 2 size of the antenna is less and multiple antennas can be used. So this MIMO technology along with orthogonal subcarrier systems used higher speeds or higher download, high data download is made possible. Yeah, as you can see here in the MIMO, at the transmit side, 2 antennas are shown. Similarly, at the receiver also, 2 antennas are shown. So, this MIMO technology, a wireless technology that uses multiple transmitters and receivers to transfer more data at the same time. So, here is a detailed comparison of 2G, 3G and 4G, starting with the year of introduction, the technology used. For example, in 4G, LTE technology is used. LTE is the trademark name of the long-term evolution. That is the full form of the LTE, and it is the trademark of the company who has introduced this technology. And similarly, access systems, TDMA and CDMA in 2G. In 3G, CDMA, and 4G also CDMA is used. And the switching types, as we see, 2G is basically an analog, whereas 3G is packet switched, and 4G also is packet switched network. That is, even voice calls are converted into packets and transmitted. Yeah. So that's all for the day, and thank you very much for carefully listening and understanding this. Thank you.